Hi guys, this is Pre-Algebra, lesson 6-1. Write two-step equations. In this lesson, we'll be able to represent a problem with a two-step equation. Let's look at explore it. Marley collects golf balls. His neighbor, Tucker, collects twice as many golf balls as Marley. And you thought they were children, but they're not. They're dogs. Here's Marley and here's Tucker, and they collect golf balls. Cute. We know Tucker collects twice as many golf balls as Marley. So whatever Marley collects, okay, you double that, that's twice. And then Tucker, you add 3 more, okay? So there's 1 basket for Marley. Tucker will collect 2 baskets and 3 more. So how can you use a table to represent the number of golf balls in Marley's collections, M, and the number of golf balls in Tucker's collection? So can you create a table? You can say, M represents the number of golf balls in Tucker's collections. Okay, wait, M is for Marley. And then the number of golf balls in Tucker's collection. Okay, so M is whatever Marley has. So if Marley has 10, we're going to show work in the middle section and then figure out Tucker's number. Okay, if Marley has 10, how many balls does Tucker have? Tucker has 2 times Marley plus 3, right? So 2 times 10 plus 3. So what is your equation? You have 2m plus 3 to get Tucker's equation, okay? So 2 times 10 plus 3 is 23. If Marley has 11 balls, you times 2 by 11 and plus 3, you get 25. Okay, 22 plus 3 is 25. 12, if Marley collects 12, Tucker collects, 24 plus 3, so 27. Okay, and so on. Gonna continue, okay? So how can you use an algebraic expression to represent the number of golf balls in Tucker's collection? So we already figured out an algebraic expression here. How can you describe that? Because Tucker has 3 more balls, 3 more than twice the balls Marley has. We can multiply 2 to m, then add 3 to show there are 3 more golf balls than twice as many golf balls. Collection. Twice as many Marley's balls in Tucker's collection. Okay. I hope the wording is not as confusing as it looks. Okay, because Tucker has 3 more than twice the balls Marley has. That's what's given information, right? We can multiply 2 to m because that's twice as many, and then add 3 to show there are 3 more golf balls. Okay, let's look at focus on math practices. How do the terms of the expression you wrote in part B relate to the values in the table? How do the terms relate to the values in the table. So how are part B and A related? Okay, what's 2m plus 3? How is 2m plus 3 related to the numbers for M and Tucker? Well, the expression 2m plus 3 has two terms, right? The term 2m represents twice the number of golf balls in Marley's collection. The term plus 3, the term 3 represents 3 more, or adding 3. Okay? So you need to be able to explain what each term represents in real life. What do they actually mean? Why do you do that? Okay, let's look at the next page. So in this lesson, the essential question is, how does an equation show the relationship between the variables and other quantities in a situation? You will not only learn how to write an equation, you will also learn how to show the relationship in real world situation. What does it mean? Okay. Example 1, write a two-step equation to represent a situation. What equation can be used to represent the numbers of golf balls in Marley's and Tucker's collection? So now we have different examples. Marley's collection is this one. Tucker has, we're doing the same example. Tucker has 3 more than twice Marley's golf ball collection, but now we know Tucker has 159 golf balls. Ooh, can we figure out Marley's then? Right? Using the equation, the expression that we had earlier, we know that Tucker's will be 2 times Marley's plus 3, right? And we know that Tucker is now 159. So can we figure out M? Yes, you can use the properties of equations to subtract 3 on both sides and get 156 equals 2m. And then divide 2 on both sides, and you get m is equal to m is equal to 78. Okay, so what does that mean? M is equal to 78. What does that mean? It means that Marley has 78 balls if Tucker has 159. Okay, you can use a bar diagram to represent the situation. And then you can use it to write an equation. So right now you can use this equation to figure it out. But if you actually figure it out, M is going to be 78. Let's look at try question. It's a different example. You're going to write an equation. You don't have to solve for it, but write an equation. See if you can do it by yourself. Okay? Okay, so Cole buys a new laptop for $335. He makes a down payment. A down payment means you're going to pay a small amount first, and then he's gonna pay the remaining amount later, monthly or in a period of time. Okay, so down payment is $50, so he pays $50 first, and he's gonna pay the rest in 6 equal monthly payments, whatever he has left to pay, which is P. What equation represents the relationship between the cost of the laptop and Cole's payments? So whatever your cost for the laptop is, which is given $335, he pays $50, right? So whatever is left is divided by 1, 2, 3, 4, 5, 6, because he's gonna pay it in 6 equal monthly payments. So what is the total of 6P? It's the cost of the laptop minus 50, which is your remaining balance that you still need to pay, right? You only paid $50. So that's going to be $285. is the remaining balance. And then you divide it by 6 to get P. But we're not solving for P right now, not just yet. Let's practice how to write equations, okay? Cost is the down payment plus the number of payments times monthly payment, okay? Which is gonna be the P. So cost is $335, down payment, he already paid $50, and number of payments would be 6 months, right? 6 equal months. He's gonna pay everything in 6 months, times P that he's gonna pay every month. So 335 is equal to 50 plus 6P is gonna be your equation. Okay, you just need to know how to write equations for now. Let's look at convince me. Why are both multiplication and addition used in the equation that represents Cole's monthly payments? Why are they both used? Why do you need multiplication, first of all? You need multiplication to determine the total of the 6 equal payments, right? What about addition? Why do you need addition? You need to combine the down payment and the total of 6 equal payments to make the final cost, right? The total of 335, you need to combine them. So let's write that down. Multiplication is needed to determine total of the 6 equal payments. Addition combines the monthly payments with the down payment for a total of 335. There you go. Okay, so that's why we need both multiplication and addition. It depends on what you are trying to get. Okay, let's look at the next page. Example 2. Write more two-step equations. A baseball weighs 25.75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box, W. In terms of the weight of the box, W is the important phrase. Okay, so weight of one baseball is already given, 5.25, right? One baseball weighs 5.25 ounces. Weight of one bat, we don't know. Minus difference in weight, okay? Difference in weight is 25.75 because we know 25.75 ounces baseball weighs 25.75 ounces less than a bat. So that means whatever bat is, you minus 25.75 to get baseball, right? So that is the difference in weight. So how do you get the weight of the bat? Weight of one baseball, you know it's 5.25. So you can use this equation instead, right? And you can say, oh, if I add 25.75 on both equations, I'll be able to get the weight of the bat. So 5.25 plus 25.75. But why could that be not true? Because you want to find the relationship between the weights of a baseball and a bat in terms of the weight of the box, W. How do you know the weight of the box? Okay, now we have another thing to consider. It's not just bat and baseball. We have the box, and box contains 50 bats and weighs W ounces. So you want to use W in the equation. You can't just say, oh, B, I'm gonna get B, right? No, you have to write the weight of the one bat in terms of W. Okay, so the box will have 50 bats. The weight of the box divided by the number of bats, how many bats you have in the box, will be weight of one bat, right? So then you can write weight of one bat as W divided by 50. And you can simplify this equation by adding 25.75 on both sides and multiplying 50 on both sides if you want to isolate the variable W, but you don't have to do it right now. This is still an equation, so it could be used to represent the relationship between the weights of a baseball and a bat using the W. Okay? We'll learn later how to isolate why W is equal to a something. Okay, let's look at try it here. Marsha and Tamara are running a race. Marsha has run 4 kilometers. Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marsha. Write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers. Okay, they give you a variable. So you know that K is the total length of the race in kilometers. And see if you can write this by yourself and come back for explanations when you are ready. I'm going to continue on with the explanation. So K is the total length of the race in kilometers. And you want to write an equation that represents the relationship between the distances each girl has run. Okay, but you need to use K. So how do you do that? What's the relationship? Well, to be honest, to be fair, there's more than one way to write an equation, but how would you know if they're all the same equation? Equations need to be equivalent equations, but there are multiple ways to write equations, okay? But there is one answer, okay? So one answer that you can use. First of all, you need to identify the important information. Marsha ran 4 kilometers. And so Marsha plus Tamara's should be the total, right? So that's K. Marsha plus Tamara is K. But we know Marsha ran 4 kilometers. Wait, the total length of the race in kilometers. Oh, so never mind. So I'm sorry. So we know Marsha ran 4 kilometers, and Tamara completed 3/4 of the race. So whatever total is, K, 3/4 is what Tamara has, right? What Tamara ran. And 3/4, so Tamara and wait, Marsha, how do we connect them? So Tamara is 2.5 kilometers ahead of Marsha. So Marsha plus 2.5 is Tamara. Okay, and we know Tamara we know that Marsha ran 4 kilometers. So she is right now at 6.5 kilometers because she's ahead of Marsha 2.5 kilometers, right? And so what can you say? That's just Tamara, but 6.5 kilometers is whatever total is 3/4 of the total. So in order to get total, you want to divide it by 3 and multiply by 4 to get the total, because this is 3/4. If you divide it by 3, you get 1/4. If you multiply that by 4, you get 1, the whole thing. Okay. So you could either write this, or you could write 4 plus 2.5 is equal to 3/4 K. They're basically the same thing. Okay. Or you could do 4 is equal to 3/4 K minus 2.5. They're all equivalent equations. Okay, there are many more ways to write it, but they're all equivalent equations. Okay. All right, example 3, interpret quantities and operations in equations. Claire bought 8 tickets for a total cost of $104. She had used the coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? So is it this, is it that, or is it that? Which one is it? Okay, so let's try to understand the situation. She bought 8 tickets. She bought, let me use a different. She has 1, 2, 3, 4, 5, 6, 7, 8 tickets for a total cost of $104. And then she used coupon code to get $3 off each ticket. So that's what she paid, but the original price is not $104. Okay. So she got a discount, $3 off each ticket. So she didn't pay 3 times $8, right? 3 times 8, which is 24. She got a total of $24 discount. And that's going to be the original amount. Okay, whatever discount she didn't pay is the original cost, right? So the original cost minus discount to cost is equal to her payment, right? We don't know what the original cost is, so that could be X. Discounted price is $3 off per ticket, so 3 times 8. And the payment she made is $104, okay? So X minus 3 times 8 equals $104, which is the same as which one? I think there's a typo in the textbook. X is the original cost of the ticket, not the difference of the cost per ticket. This is when X is a different thing. So this is not true. If X is the original cost per ticket, then it's X minus 3 times 8 equals 104. But if we're saying X is the difference of the cost per, X is the cost per ticket. So here, this X represents the cost per ticket. But X needs to be the original cost of each ticket. Okay, so this doesn't make sense either. It just needs to be X minus 3 times 8 equals 104. I'm sorry that we have a typo in the textbook, but it happens, and that's okay. Let's look at try it. At the mall, Claire buys a hat that is 60% off and socks that are reduced to $5.49. She spends a total of $9.449. Let X represent the cost of the hat. Which of the following equations correctly represents Claire's shopping trip? Okay, so she buys a hat that is 60% off and socks that are reduced to, so not the original cost, but it's now $5.49. She spends total of 9.49. If X is the cost of the hat, how can we represent the equation correctly? Well, whatever the cost of the hat is, if you have 60% off, how much are you paying? You're paying 40% of the price, right? So you want to multiply 40%, 0.4 times X to pay Claire, and to get whatever Claire paid for the hat. And then she paid 5.49 for stocks, and total is 9.49. So which one is correct? This one. Okay. All right. So let's summarize our lesson. You can write an equation with more than one operations to represent a situation. Okay. You need to know what the terms represent. It's very crucial to writing the correct equation to represent your situation. Okay, that was lesson 6-1, writing two-step equations. And the next lesson, 6-2, we'll learn about solving two-step equations. So it was all about writing equations. We didn't have to solve it, but we're going to solve it in the next lesson. All right, I'll see you in the next video. Bye.